All right, gentlemen, let's take a look at some more shifts for trig functions, right? We had done the other day amplitude changes and then like horizontal stretches and shrinks. So let's just look at two more. But first, let's review those ones that we know. So we know that amplitude is the distance between the center of the function, which is usually the x-axis, and then either the top or bottom of the function. And that's what we saw when we saw vertical or stretches and shrinks, and that was when the a value was different, meaning the function looks something like this. A sine of x, right? And the a was the new amplitude, right? So if it's not there, it's a 1. If it's a 2 or a 3 or a 1/2, that's something else. That means that's the new amplitude. Frequency is the number of cycles in 2 pi. And the example I gave in my Zoom was like blinking. If I were to say how often, what's the frequency of my blinks, you would naturally ask, well, in how long? A day, or in an hour, or what do you mean? The same idea. What is the frequency of a full cycle in 2 pi? And 2 pi is like our standard unit, because that's 360 degrees. And the period is how long to do one full cycle. So the example I gave with the blinking again would be, how long does it take me to do one blink? Meaning, eyes open, eyes close, eyes open, right? That's a full cycle. If I were to just do eyes open, eyes closed, that's half, right? So we want a full cycle when we get back to where we would repeat again. Okay, so, and then the frequency and period was related to horizontal stretches and shrinks, and that was all related to last class's Zoom. Okay, so now let's look at two more, and then we'll do about 2 examples of each. So just as we saw in the second trimester, vertical shifts, meaning sliding it up or down, is relating to adding or subtracting on the outside of the function, meaning not within the f of x. Right, and as we saw, plus d, right, just as we saw in the second trimester, was sliding it up d units, right? So take the function and slide it up d units, and then minus would be take the function and slide it down d units. And vertical was always very intuitive, same with amplitude, where the vertical stretch or shrink kind of made sense. If it was a 2, there's a new amplitude of 2. The frequency and period, which is the horizontal ones, those tend to be a little bit weird, where you kind of have to look at it a little bit better. So, and these are the harder ones, horizontal shifts. That's when you go left or right, and that's adding or subtracting on the inside, right? And that's the difference, either adding and subtracting on inside or outside. And we saw that whenever it was horizontal, it was kind of opposite. So plus z would actually mean to the left c units. And then minus c would be sliding it to the right c units. Okay? And that was something we had seen when we did it in the beginning of the second trimester. And just to kind of reiterate the rules that we know. So they still apply here. These aren't different functions. These are just trig functions, so they follow the same rules. So let's do a couple examples. First, of just the vertical shifts. Okay, so we see here sine of x plus 2, right? We know that sine looks like this, right? So I'll draw the regular sine, and we know that it goes every 90 degrees, or every pi over 2. It starts at 0, then it goes to 1, to 0, to -1, and back to 0. And that's a full cycle, so we'll do that here. 0, 1, 0, -1, 0. So here's my normal sine of x. Okay? And there's typical sine. Now let's take everything and slide it up 2 units. So I normally start at 0. Now I'm starting at 2. 1, 2. I normally start at the second part at 90, at pi over 2. I'm at 1. Now I'm going to be at 3. I'm normally at 0, so now I'm going to be at 2. I'm normally at -1, so now I'm going to be at 1, 2. And so I'm going to be up at 1. I'm normally at 0. I'm going to be back over here. And we see that this graph is exactly the same as the one below. It's just that it's slid up 2 units. Okay, it says here from negative 2 pi to 2 pi. I'm only going to do this part because I want to do that more for like the horizontal changes one, because you want to see what it looks like on the other side. So for this, I'm just going to leave it like this. But you would just continue it on the other side, right? And you would kind of see that this would go down to negative 1, and then 0, and then positive 1, and then 0. And here is sine on the other side, and the green would be exactly the same, just up 2 units. Pretty straightforward. Cosine. So now cosine, we know, looks kind of like a U, and it starts at 1, goes to 0, goes down to negative 1, back up to 0, back up to 1. And again, that's every 90 degrees, or pi over 2. Okay, so we're doing the exact same thing, except we're going to be sliding it down 3 units. So start at 1, go to 0, go to negative 1, go back up to 0, go back up to 1. Here's my little curve. There we go. And that's regular cosine of x. Now if I take this and I slide it down 3 units, well, here's down 1 unit, here's down 2 units, here's down 3 units. So now I'm starting there. Now I'm at 0, so I go down 1, down 2, down 3. Down 1, down 2, down 3. Pretty low over here. Now we're going to kick back up. Down 1, down 2, down 3. Down 1, down 2, down 3. Right, and the idea being that we are taking every single point, the ones that we're familiar with, and just putting them 3 units lower than what they're usually at. And there's cosine of x minus 3. All right, and if I were to continue, cosine's pretty easy, where it's very symmetrical over the y-axis, and it just continues like that. And I would do the same for the green, but for the time being, I'll just leave it like that, right? So there's your vertical slides up and down. Very straightforward, for the most part, pretty easy to follow. Now, what about down here? These are horizontal, and these are a little bit harder. I'm going to take what I wrote right here, and I'm going to bring it back over here, and then here's my one for cosine, and I'm going to bring that over here. All right, so I'm going to do these two. First, looking at sine. Okay, so what do I know from this information? Pi over 2. That's 90 degrees. Plus, that means to the left. Okay, so that means I'm taking this, which is my normal pattern, 0, 90, 180, 270, and 360. And I'm going to slide this whole thing to the left, so it's like if this, and then this pattern repeats after this, right? So then it goes 1, 0, negative 1, 0. It just would repeat again. So instead of starting here, I'm going to slide it over 90. So I'm going to take this whole thing and slide it to the left. So now I'm starting here. Okay, I hope we all saw that, right? So I'll do that again. I normally start here, but because I'm sliding it over by how much? By 90. So with these numbers, it's just 1 unit over. So instead of starting here, I'm now going to start here. I'm going to follow the same pattern. It's just now I'm starting at the 90 number. Plus 90 means now I'm starting. Slide it all to the left. I started the number to the right, right? So it's kind of, that's why it's a little bit difficult, because it kind of works opposite. Let's draw a normal sine. Up to 1, to 0, to negative 1, to 0. And here is sine. Okay, and I'll do it on the other side. Back to negative 1, and then to 0, and then to positive 1, and then to 0. And there we go. Okay, so there's regular sine. Now I'm taking this and I'm horizontally shifting it. Okay, so now, as we said up here, instead of starting at 0, I'm going to start at 1 here. Now I'm following the same pattern. So then at 180, I'm at 0. Oh, I'm sorry. Then at 90, I'm at 0. So now this is 0, 90, 180, 270, 360. All right, so I just relabeled those. I like to do that. So I started at 1, and now I'm at 0. Then I'm going to do negative 1. All right, so I'm even with these. It's just I'm picking different y values. So here, I'm going to be at 0. And then where do I go at 360? Well, I'm over 1. I'm now at 1. And and here's my sine curve shifted over. And I could follow suit on the other side. I'll kind of start at the same point, so I'll start here, just like here at 0, and I went up here. And then I went down, down, up, and then I go to there. So here's my new function, right? And I'll just erase some of these points. All right, so the key is I like to write out this part, and then say if I'm shifting it over, I now get rid of this, and I relabel on the bottom, 0, 180. So now I know I'm over by one number. And how do I know that? Because I'm over by 90. Now, if you notice this, what is this? Well, this looks exactly, right? So this is sine of x plus pi over 2. But if you look at the shape of this graph, it also looks exactly like cosine of x. Is that a coincidence? Of course it's not. Because sine and cosine are co-functions, right? And you're shifting it over the correct way, right? If you shift it over the other way, you won't be exactly right. But because you shift it over this way, they match exactly. And that makes sense because sine and cosine are complementary. So sliding it over by 90 does make them match, right? And pi over 2 is 90, right? Because complementary means you can use the 90 minus number to get it right, to get it to be equal. And this is kind of exactly what's happening here from the graph point of view. So pretty intuitive. If you were to have minus pi over 2, you're sliding it the other way and you're like off by 270. So just be careful with that, but it should not be too much of a surprise that shifting it by 90 makes a match. All right, let's do it with cosine. Okay, so we see y is equal to cosine of x plus pi. What is pi? 180 degrees. Plus means I'm shifting it to the left. Right, so again, just as we saw over here, plus and plus, I'm shifting it to the left. So here's my numbers, and this is every 90, so very nice. Every 90, I'm actually going to write this over here. Okay, so now this is 0, 90, 180, 270, 360. That's normal. But since I'm shifting it to the left, so I'm taking this and shifting my values to the left, I'm not going to start here where I normally would. I'm not going to start here, and I'm going to start here. How do I know that? Well, I'm shifting by 180. So now I'm starting at 180. And then we'll just continue the pattern, right? 0, -1, 0, 1. 0, -1, 0, 1. Right, so there's your pattern. So now I know I'm going to start. So my 180 is my new starting point. So now this is technically my new graph, 0, 90, 180, 270, 360. Right, so there's our new graph. Right, and how do I know I'm sliding over my values? Well, because it says slide to the left by 180 degrees. So now I'm starting at the number 2 over from that. Okay, so let's start by drawing normal cosine. 1, 0, -1, 0, and 1. And here we go. Nice cosine graph. And there's cosine of x. Now, this is not going to match up totally with sine like the previous one is because I'm sliding by 180. So it's not going to be exactly correct, exactly on top of each other. Okay. So now let's look at our shift. So now I'm starting at -1. So I'm going to start down here. How do I know that? I'm sliding over to the left by 2 values. My next number would be 0. So they overlap right there. Then I go to 1. So now I'm at 1. Then I go to 0. Then I go to -1. Right, so we see that I'm following the exact same pattern of numbers. It's just a matter of, am I shifting to the left by 2, to the right by 2 of the numbers, right? Meaning every unit's of 90. And here, right? So it'll go like this. And we see it goes like that, right? So it's like a DNA strand, right? Because you're taking it exactly and you're sliding it over halfway. So it's opposite, right? And now I'll do the same, right? I'll continue cosine normally where it goes 0, -1, 0, and 1. That's normal cosine, right, in blue. And now I'll do it shifting it, right, where I'll follow the same numbers backwards. A little bit harder to go on the other side, but right, I'm normally at, you can kind of follow the DNA pattern here, but if I'm at -1, I'm going backwards. I'm going to be at 0, 1, and then I go after 1 going backwards, I'm at 0, and then after 1 going backwards, after 0 going backwards, I'm at -1. So a little hard to go backwards, but you just, if you know the number, the pattern of the numbers, you can kind of follow suit. And this is plus pi over 2. Okay, so a little difficult, but just keeping in track. I like to write out my values right here, as we can see right here, and then rewrite them. And that's how I know how to follow suit. Okay, I'll do one with minus. I'll do this one with minus, and then this will be the last one. Sine. Not this. I'll take this one. I like this one better. Duplicate. Okay, here's sine. Okay. Right, and I'll just write out, I'll actually write this out a little bit more just because we're going minus. So 0, then you go 1, 0, -1, 0, 1, 0, -1, 0. So there's our pattern. And it's every, right, there's our pattern. So let's draw a sine. I go 0, 1, 0, -1, 0. -1, 0, 1, 0. And here is normal sine of x. Okay, I just followed those numbers. I like to write out the whole thing. Now I'm shifting this pi 180 degrees minus to the right. So I'm shifting this whole graph this way. All right, so here's my normal sine. If I start in the middle, I'm going to go 2 to the right. So I'm taking this and I'm going to have 2 more numbers on the opposite side to the left, right? If I take this and I slide these over, it's almost like if I went like this. Let's try this. I think this will help if I take it like this. Sorry, guys. Okay, right? I'm taking these and I'm sliding these values 2 to the right. So I'm taking this and going 1, 2. So now those are my values. Right, if I do that again, normally I start at 0, 1, -1, back to 0, and then I repeat. So I'm sliding 2 to the right. 1, 2. I think that's pretty helpful. I like to do that. I think it helps me a lot too. So those are my new numbers. So now I'm starting I'm starting at 0 still, because that's where I'm at. And then I go -1. So now I'm going down 1. And then I go back up to 0. And then I go up to 1. And then I go to 0. And then going the other way around, it's the same as previously, where you're just always opposite. So I'm at 1, and then I'm at 0, and then I'm at -1, and then I'm at 0. Right, and there's sine of x minus pi over 2. Right, so I hope that notability thing helped, where I slid the numbers over. I think I like to write out the pattern of numbers, so I know I go 0, 1, -1, 0, -1, 0, and I repeat that every time, and then I just draw my little sections and I slide it over so I know exactly where to start. Okay, the last one will be the same thing, except you just slide it the other way. Okay, so I hope that's helpful. You have some classwork down below here where you're doing, I think, 8 problems just like this. Try your best on it. We'll leave some comments on your work, and then we'll pick up with this. We'll do a review of all transformations next time, so we're not going too far ahead with next class. So if you're a little confused, we're going to review it some more next